Hello friends, this is third part in organic chemistry, basic principles and techniques. In our last session, we have studied some purification techniques like sublimation and simple distillation, crystallization. Today we shall see other forms of distillation beginning with fractional distillation. Under distillation, we have studied only simple distillation. So today is second distillation, which is fractional distillation. In simple distillation, we have studied that you can purify only those organic liquids whose difference in the boiling points is very large. If there are any two liquids whose boiling point difference is very small, say 10 to 20 kelvins or 10 to 20 degrees Celsius, then they cannot be separated by simple distillation. Why they cannot be separated by simple distillation? Because you cannot control the temperature the fire is giving to the round bottomed flask. So when the solution or mixture of liquids in the round bottomed flask is getting heated continuously, then due to continuous supply of heat, both the liquids which are now having very less difference in their boiling point, both of them will vaporize simultaneously. Vapors of both the liquids will come through the water condenser and the receiver will contain again both the liquids. As a result, simple distillation is not advised for purifying and separating those organic liquids whose boiling point difference is very small. Then what should be done? Then such liquids are subjected to fractional distillation. Their separation can be done by fractional distillation. So what is fractional distillation used for? It is used for purifying those organic liquids which differ in their boiling points by 10 to 20 kelvins. I mean, if the boiling point difference of the organic liquid mixed is very less, then they can be purified by fractional distillation. How is it different from simple distillation? The only one difference is, in simple distillation you can purify liquids whose boiling point difference is large, and in fractional distillation you can purify even those liquids whose boiling point difference is very small. This is the principle of fractional distillation. And the second difference is, in fractional distillation you have one extra apparatus, which is a fractionating column. Let us see how apparatus is set and then we shall explain. So in fractional distillation, the same setup that you have a round bottomed flask. A round bottomed flask is present. This round bottomed flask is kept on a stand. It is kept on a wire gauze which is kept on a stand, and then this wire gauze rests on a stand beneath which you will have a burner. Then this round bottomed flask is fitted with a fractionating column. What is a fractionating column? A fractionating column is a glass apparatus. A fractionating column is a glass apparatus with different designs. It comes in different designs, the purpose of which I will tell you after some time. This fractionating column is fitted over the round bottomed flask's mouth. It is fitted over the round bottomed flask's mouth. In simple distillation, this round bottomed flask was directly connected to water condenser, whereas in fractional distillation, this round bottomed flask is first fitted with the fractionating column. This fractionating column has got a side tube. This has got a side tube which is connected to water condenser. Rest of the things remain same. Here you will have a closure with cork with a small space or hole in between for fitting a thermometer. So you will have a thermometer here. Okay. Now this is a thermometer. This side tube is connected to a water condenser. And this water condenser opens into a receiver. This water condenser opens into a receiver. Okay, so here is the water condenser. Water condenser has got two openings. One is connected to water tap and the other is connected to sink, and the water condenser should be supported on a stand. The same should be done even for round bottomed flask. It should also be supported on a stand. Okay. After the diagram is done, now you continue with labelings. Now you will have a support for round bottomed flask and fractionating column also. Okay. Then you will have mixture of organic liquids here. The experimental setup for fractional distillation is the same as for simple distillation, and the only difference is that the round bottom flask is connected with a fractionating column. A fractionating column comes in different designs. One of the design is given. For more designs you can refer NCERT textbook. So this is round bottomed flask and here is impure liquid mixtures, impure liquid mixture. Then you know common labelings, I will not do. So this is Bunsen burner. This and this are stands, and this is fractionating column, which is an important part in fractional distillation. Then this is thermometer. Then this is side tube. Then this goes to sink. This has the connection to water tap. And here is our water condenser. Then the last is receiver. Now once the experimental setup is done, you go through this. The experimental setup is done as shown in the figure. The mixture of organic liquids which has got very less difference in their boiling points, they are taken in round bottomed flask. Okay. After that is done, the liquids are heated. Upon heating, when you have two liquids which have very less difference in their boiling points, now they will begin to boil simultaneously. They will begin to boil simultaneously. Let us consider this example. You take the example of methanol and acetone. The best example to understand fractional distillation is methanol and acetone. Methanol boils at 65 degrees Celsius and acetone boils at 56 degrees Celsius. So if you have these two liquids as a mixture, now they are mixed and you want to separate them, then they can be done by fractional distillation. Now before we begin the procedure, you should know what boiling point is. You might be knowing, but still I'll say boiling point is defined as the temperature at which a liquid boils. That's true. It is also that temperature when the vapor pressure of a liquid becomes equal to the atmospheric pressure. Okay, it is also the temperature at which vapor pressure, that means pressure on the surface of liquid, becomes equal to atmospheric pressure. So now you have got two liquids here. What are the two liquids? Methanol and acetone. Both of them have very less difference in their boiling points, around 10 to 11 degrees Celsius. So if this liquid mixture is taken in round bottomed flask and heated, vapors of both the liquids will pass through here. They will go through fractionating column. Now when the vapors of both the liquids are passing through the fractionating column, the fractionating column sends out only one liquid vapors. Now which liquid vapor is that? To understand this, remember this sentence. The liquid which has got higher boiling point, mark my words, the liquid which has got higher boiling point has a tendency to condense first. This means if a liquid which is having higher boiling point, it boils and converts into vapor, it will condense first. Than whom? Than that liquid which has got lower boiling point. So now you have got two liquids here. When both the liquids are passing through the fractionating column, then which is our liquid with higher boiling point? It is methanol. So when methanol and acetone both are moving upwards, the liquid with higher boiling point has a tendency to condense first. Okay. So when it enters, so when both the liquids enter into the fractionating column, I mean methanol and acetone, out of these two, the vapors of methanol will condense first. Okay, but they will not go out. The vapors of methanol will not go out. The vapors of methanol will condense first. How do they condense? This fractionating column has got ridges. It has got these ridges. What is the work of these ridges? Its work is to, the role of fractionating column is to hinder. Hinder means stop, obstruct. The role of fractionating column is to hinder or oppose or obstruct or stop the movement of vapors as they rise up into the fractionating column. The fractionating column stops or opposes the movement of vapors while they are rising up. Now I said there are two liquids, both of them will vaporize at the same time, but when they enter into fractionating column, only the vapors of the liquid with a higher boiling point will condense first. Okay. So which vapors will condense first out of methanol and acetone? It is methanol vapors which are condensing first. This was my first statement, that the liquid with higher boiling point has a tendency to condense first. This was first statement. Now the second is, in doing so means when the liquid with higher boiling point, its vapors are getting condensed. After getting condensed, it will emit heat. It will emit energy in the form of heat. That heat is taken up by the vapors of the second liquid. The heat emitted by the vapors of the liquid with higher boiling point, that heat is taken by the liquid with lower boiling point. And what happens if this takes up the heat of the first liquid? Acetone or liquid with lower boiling point will remain in vapor phase only. So when methanol and acetone both are entering inside the fractionating column here, methanol has higher boiling point and acetone has got lower boiling point, then the vapors of methanol has a tendency to condense first. In doing so, it liberates heat. That heat is taken up by acetone. Therefore, acetone will remain in vapor form only, whereas methanol, after striking these ridges and graduations, it falls back. While falling back, whatever heat is given out, that heat is taken by acetone. So the vapors that come out of the round bottomed flask, that come out of the fractionating column, they are not of methanol, they will be of acetone. So when the vapors enter inside the water condenser, this portion is always filled with continuous flow of water. As a result, the water condenser makes the inner channel cool. As a result, when the vapors of acetone pass inside the water condenser, these vapors get condensed back into liquid. These vapors will get condensed back into liquid, and the same vapors, after condensing into liquid, they are collected into the receiver. So here in the receiver you will have acetone and you will not have methanol. Where remains the methanol? It remains in the round bottomed flask. Now what if some methanol also escapes? It is not possible to exactly separate the two liquids into cent percent in the first try itself. I mean to say, both the liquids have got very less difference in their boiling points. So when they boil, one of the liquid, that is liquid with higher boiling point, will not go out. Instead, it will send the other liquid, the liquid with lower boiling point, outside. Sometimes in the receiver, the distillate, that is the liquid acetone, may have small portions of methanol also in it. What should be done then? You have not separated properly. Then fractional distillation should be repeated again. That's all. You should carry out fractional distillation as long as both the liquids are separated completely. This is fractional distillation. I'll revise this once again in brief. The main principle of fractional distillation is that if there are two liquids which have got very less difference in their boiling points, then they cannot be separated by simple distillation, as the receiver will have both the liquids. For this reason, fractional distillation technique is used. In this technique, a fractionating column is used, which is the only difference from simple distillation. What is the role of fractionating column? The role of fractionating column is to stop or obstruct or oppose or hinder the movement of vapors as they rise into the column. Based on this principle, the experimental setup is done as shown in the figure. How is the experimental setup done? The round bottomed flask is fitted with the fractionating column, which has got a side tube and a thermometer. The side tube is connected to a water condenser, which opens into a receiver. The experimental setup is same as in simple distillation except a fractionating column. Now, the mixture of impure liquids is taken in the round bottomed flask and heated. Upon heating, vapors of both the liquids are formed, but remember, the liquid with higher boiling point has got a tendency to condense first, and in doing so, it emits or releases heat. That heat is taken up by the vapors of the liquid with low boiling point. Hence, the latter, the liquid with lower boiling point will remain in the vapor form only. The liquid with the lower boiling point will remain in the vapor form only. Hence, the vapors that escape out of the round bottomed flask and fractionating column are the vapors of liquid with lower boiling point. If you have chosen methanol and acetone, then the vapors which come out of the fractionating column are of acetone. When these vapors pass through the water condenser, these vapors get condensed back into liquid and they are collected into the receiver. It may so happen that sometimes the receiver might contain a small fraction of the liquid with higher boiling point also. In such cases, what is done? In such cases, the technique or the procedure of fractional distillation is repeated again. Till when is it done? It is done as long as you are not confident that the two liquids are separated. That's all. So if I ask you, name one example where fractional distillation can be used, you can write methanol and acetone. If you have got two liquids whose difference in the boiling point is large, which technique will you use? You will use simple distillation. If the boiling point difference is very small, which technique will you use? You will use fractional distillation. How is the apparatus different? A fractionating column is present in fractional distillation, that's all. What will you do if after fractional distillation the receiver has got other liquid also? Then fractional distillation is repeated again. Understood? Okay. So this is fractional distillation. Now let us see another distillation. It is distillation under reduced pressure. It is distillation under reduced pressure. This is the third distillation technique. This is third distillation technique. Now before I explain what distillation under reduced pressure is, let us study the principle. This technique, that is distillation under reduced pressure, it is used to purify those liquids which can decompose at their boiling points or which can decompose below their boiling points. You may ask, sir, in what way should I understand decomposing? I said this technique is used to purify those liquids which decompose at or below their boiling points. So in what way should I understand what decomposing means? Decomposing means losing their identity. Sometimes you have got liquids which boil at different temperatures. Water boils at 100, that is fixed. But you also have some liquids which can boil at two different temperatures. So one best example to remember for distillation under reduced pressure is for glycerol. You also know it by the name glycerine. So glycerol is one liquid. Glycerol is one liquid which boils at 290 degrees Celsius. It boils at 290 degrees Celsius. But by using distillation under reduced pressure, you can make this liquid to boil at 180 degrees Celsius. You can make it to boil at 180 degrees Celsius. How? I did say it is used to purify, this technique is used to purify those liquids which decompose at or below their boiling points. Means glycerol's normal boiling point is 290. But it is made to boil at 180. So glycerol is one liquid which is undergoing decomposition, which can decompose. Understood? So it is one technique used to purify those liquids which decompose at or below their boiling points, and it is also used to purify those liquids which have got higher boiling points. Like acetone and methanol, they cannot be purified by this method. In order to purify a liquid by distillation under reduced pressure, you need those liquids which have got higher boiling points. Okay. Now based on these two concepts, we have glycerol as an example to understand how distillation under reduced pressure works. Now I a moment before I told you what boiling point is. Boiling point is defined as the temperature at which a liquid boils, isn't it? Then it is also the temperature at which vapor pressure becomes equal to the atmospheric pressure. You might not have understood the second sentence or the second definition. I said it is the temperature at which vapor pressure becomes equal to atmospheric pressure. Now how do I understand this? You will understand this in this way. See, every liquid in a container has got its surface. Okay. Vapor pressure refers to the pressure on the surface of a liquid. Vapor pressure is nothing but the pressure on the surface of a liquid. When this pressure on the surface of liquid becomes equal to the atmospheric pressure, when it becomes to the external pressure, only then a liquid will boil. That is also boiling point. Boiling point is the temperature at which a liquid boils, and when a liquid boils, it boils only when its vapor pressure, when its pressure at the surface becomes equal to the atmospheric pressure or external pressure. That is boiling point. Now if somehow you reduce this temperature, if you reduce the temperature over the surface of a liquid, if you reduce the vapor pressure of liquid, then that liquid can be made to boil at a lower temperature. That is the main principle behind distillation under reduced pressure. If you have not followed, I will repeat once again the principle. We know that the boiling point of a liquid is the temperature at which a liquid boils, at which a liquid gets converted from liquid to vapor phase or gaseous phase. But boiling point is also defined as the temperature at which its vapor pressure becomes equal to the atmospheric pressure. Means the pressure on the surface of liquid becomes equal to the external pressure. Now if the pressure on the surface of liquid is somehow reduced, then that liquid can be made to boil at a lower temperature than its normal boiling point. This is the basis for distillation under reduced pressure. In order to carry out this technique, you need a special apparatus which is called Claisens flask. It is similar to a round bottomed flask. Let us see how the experimental setup is done. So for this technique you need a Claisens flask. What is Claisens flask? A Claisens flask is a double necked flask. It is a double necked round bottomed flask, you can say that. The only difference is it has got two necks. So round bottomed flask with two necks is called Claisens flask. Then this Claisens flask is kept on a sand bath or a water bath depending on the conditions. If required you can use, otherwise no. The sand bath or water bath is kept on a wire gauze. Sand bath or water bath is kept on a wire gauze which is now kept on a stand. Okay, which is now kept on a stand. Then this is Claisens flask. In the Claisens flask you have, in the first neck you have a very thin tube, which we call as a capillary tube, a very thin tube called as capillary tube. This capillary tube is regulated by means of a stopcock. Then the mouth of Claisens flask is closed. The other neck of the Claisens flask is provided with a thermometer. Okay, it is provided with a thermometer and its mouth is also closed. Its mouth is also closed. Then it has got a side tube. It has got a side tube. it has got side tube. What has got side tube? The second neck of Claisens flask has got a side tube which gets connected to water condenser, then the water condenser is connected to receiver. This much apparatus was okay. You have some extra additions also. First I label here, this is Claisens flask. It was devised by Claisen, so it is called Claisens flask. Then you have capillary tube, a very thin glass tube, it is capillary tube. Then you have impure liquid. This is one neck, second neck, this is thermometer. This one is side tube. Then other are common. The extra additions are that the receiver is connected to a vacuum pump or to a water pump. So this is to vacuum pump, this is normally receiver, and the vacuum pump is then connected to an apparatus called manometer. It is connected to an apparatus called manometer. What is manometer? Does anyone have any idea what manometer is? A manometer is any apparatus that is used to check the pressure. So this is a manometer. If this experimental setup is understood, then we can explain what distillation under reduced pressure is. So the liquid which is to be purified is taken in Claisens flask. I did not draw stand here, so you can understand if I have not drawn. This Claisens flask is supported on a stand. It is supported on a stand. Okay. So the impure liquid which is to be purified is taken in Claisens flask. It is connected to water condenser. Water condenser is connected to receiver. Receiver is connected to vacuum pump, which is then connected to manometer. Now, the liquid in the Claisens flask is heated. Okay. After heating, vapors should be formed. Vapors of what? Glycerol should be formed. These vapors get condensed back into liquid. Now, what happens exactly in this technique? You are making that liquid to boil at a lower temperature than its normal boiling point. How is it done? It is done first by capillary tube. The purpose of this capillary tube is it is kept open from here. Whenever needed, it is closed. Otherwise, it is kept open. So air from the outside is constantly flowing inside the Claisens flask. It is constantly flowing inside the Claisens flask. As a result, these air bubbles tend to apply pressure on the surface of liquid. They tend to apply pressure on the surface of liquid. It is one work. The second is the pressure inside the Claisens flask is regulated by means of vacuum pump. The purpose of vacuum pump here is it is used to reduce the pressure inside. The purpose of vacuum pump is used to check the pressure inside the Claisens flask, which is done by an instrument called manometer. Manometer helps in regulating the pressure. What pressure do we need? That pressure is maintained by manometer. You can check the level of the pressure from manometer, and for checking the pressure you use manometer. and for increasing or decreasing the pressure you need to use vacuum pump. So by vacuum pump the pressure here is put on the liquid, and from here also pressure is applied on the liquid. As a result, the liquid which was to boil at regularly 290 degrees Celsius, because of reduced pressure it will now boil at 180 degrees Celsius. Understood? Nothing is different from the other techniques. The only difference here is you are applying pressure on the surface of liquid as well as below the surface of liquid. Below the surface of liquid, who is applying pressure? It is the capillary tube which pumps air inside, and from above it is vacuum pump. Who regulates the flow of air inside? It is capillary tube. And who controls the pressure from above the surface of liquid? It is manometer. So under reduced pressure, glycerol which was to boil at 290 degrees Celsius will now boil at 180 degrees Celsius. The vapors of glycerol will pass through the Claisens tube and pass into the water condenser. In the water condenser, those vapors will condense back into liquid, and the same liquid is collected into the receiver. This is one of the best techniques that manufacturers, soap manufacturers use after the glycerol is left behind. During manufacture, whatever glycerol is left behind, it is recollected by using this technique. So today we have studied one distillation under reduced pressure and the other was fractional distillation. In our next class we shall study one more distillation which is steam distillation. That's all for now. Thank you.